So, we don't even have to do any math. We can already tell what the vertical asymptote and the horizontal asymptote is, right? So where do we look?
The equation.
It's where we used to look for the vertex. We're on the back of the page. So what are the asymptotes? Yeah.
They are y equals 2 for the horizontal asymptote.
Not quite.
X equals 2.
Yeah. So y equals 4 is the horizontal. And then x equals 2 is the vertical. So the opposite of the inside of the function still tells you like the x coordinate, but in this case it'd be the vertical asymptote, which is in terms of x. And then the number on the end, exactly as it's written, still gives you like the y coordinate, which in this case would be the horizontal asymptote, that's y equals something. Okay, so we're going to take the points that are from the parent graph. What were the points for this parent graph, the one that has a squared? What were the points that we would use? So flip your paper back to the front. Yep. -2. Positive 1/4. And then -1. 1. And then we have the asymptote, right? Because if we plug in 0, it would be undefined for the parent graph. And then we have 1, 1, and then 2, 1/4. And what are the transformations that we can see? So we're going to reflect over x. What else? Right 2 and up 4. Okay. So what do we do to the points when we reflect over x? Change the sign of the y coordinate, because if it was up, it's going to flip so it's down. So we're going to change the sign of the y coordinate. So -2, -1/4, -1, -1. Vertical asymptote doesn't do anything when you reflect over x. So I change the sign of all my y coordinates. Then I can shift everything to the right 2. So what would I get? Zero. -1 shifted to the right 2. 0 shifted to the right 2. 2, right? Which fits, right? That fits the information we had. That's our vertical asymptote. 1 shifted to the right 2. 3. 2 shifted to the right 2. 4, okay. And then we have our y coordinate, and we are shifting up 4. So we've got -0.25, 3 3/4, or you could say 3.75. -1 shifted up 4. Vertical asymptote's not going to move if you shift it up and down. -1 shifted up 4 we said is 3. And -1/4 shifted up 4 we said is 3 3/4. Okay, so we can draw in the asymptotes. So 0 and 3.75 would be like right up there. 1 and 3 is right here. And we know that when we have asymptotes, the curve follows the asymptote. And then we have 3, 3, and then 4, 3.75. So for the domain, we have all of the x values, but we have to skip one of them. 2. So for the domain, we're going to say negative infinity to 2 and 2 to infinity. For the y values, we only have the y values underneath the horizontal asymptote. We don't have any y values above the horizontal asymptote. So this is different than the other two examples we did. The other ones had a curve on top and a curve below. These only have curves below. So the range would be negative infinity to 4. Bracket or parenthesis with the 4?
No, parentheses.
Parenthesis, it's an asymptote, so we don't actually hit 4, we just get close to 4, yeah. Okay, x-intercepts and y-intercepts, we gotta graph those on our calculator.
Oh, but doesn't it already give you the x and y intercepts? Because it never reaches the x-intercepts and the y-intercepts.
Oh, it reaches the x-intercept right there.
Oh, my bad. I was looking at the x.
You hit alpha y equals. Do you guys want to type it in as a fraction, or we're okay with that? Okay, so I've got negative, and then I hit alpha y equals, and I can do 1 over x minus 2 squared plus 4. We already know the y-intercept because it's right here. So we don't have to find that one. But we can go ahead and find the x-intercept. So we got second trace number 2. We got our left bound. We got our right bound. So we got 1.50. Left bound, right bound, 2.50. Okay. Is there a max or a min? Mountaintop or a valley?
No.
Nope. And there never will be for these. Not when they're simple like this. In pre-calc, you look at rational functions that are kind of, it's like the ones that we were adding and subtracting and multiplying and dividing, but you actually graph ones that look that complicated. Those ones have mountaintops and valleys all the time. But ones that are simple, where it's 1 over x or 1 over x squared, those will not. Increasing and decreasing, I'm going to go ahead and draw a little sketch. So we have a stick figure. This is negative infinity. What is our stick figure doing? Yeah, decreasing into a black hole. What is the x coordinate of the black hole? 2. So this is the x value, right? Is 2. So he decreases from negative infinity to 2, and then that stick figure is gone in the black hole, and another stick figure crawls out of the black hole. And this stick figure is doing what? Climbing out of the hole. What's the x value over here? Infinity. Okay, so for increasing, what answer are we going to write? 2 to infinity, right, because x coordinates. And then for decreasing, what are we going to write? Yeah. So you'll notice that the increasing and decreasing are a little bit different than they were on the examples from last night, right? Because last night the two curves were either both increasing or both decreasing, but when you have the two curves on the same side of the asymptote, they end up being 1 and 1. 1 increasing, 1 decreasing. Yes. 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 Mm-hmm. Okay. Is the graph? Sorry. Yes.
Is it continuous? Because if you zoomed out enough, they both meet at 2. No, because
they don't meet at 2.
They never touch 2.
They never touch 2.
Okay.
So if you zoomed out forever, you would just trail down forever. You'd just be following it down forever and ever and ever and ever and ever. Then time would pause. There'd be some sort of explosion or something. And then your finger could jump to the other side, and then you'd be going back up. All right. So this is not a continuous graph because you do have to pick up your finger to hop over the asymptote. So it doesn't show up as continuous on your calculator. There's a space. Yours might have drawn an asymptote in there, but it's not continuous. Some calculators will actually put a vertical line in there for the asymptote, but it doesn't mean that they touch. Yeah. They'll get very, very close to touching, but if you zoomed in, you'd be able to see that they can't touch ever. Okay. The end behavior, so we're going to say as we look to the left, as we look to the right. So what y value is this one going to get close to on the left side?
4.
And what y value on the right side?
4.
4. So when we do end behavior for these, they don't go up or down forever. They actually get closer to the asymptote. So we use the asymptote. So these are interesting because we haven't really had graphs like that before. Because that's not left and right, that's in the middle. Yeah, so left forever, right forever. Okay, so let me go ahead and give you your assignments. We'll make sure that we're okay. Now, normally, this kind of matches what we've done for a lot of our worksheets, right? You want to put it in the box? Yes, there's no Bitmoji, so sorry. So normally when we look at graphs, we do have one page that says find the transformations, and it normally says find the vertex, but this one doesn't say find the vertex. What are you finding instead of the vertex? The asymptotes. Okay, so we're going to say x equals 3, right? And then we're going to say y equals 1. And so this is the horizontal asymptote. And the other one was the vertical asymptote. Squared just means it has a different parent graph. That's not a transformation. That would just be saying the curves are on the same side. So as far as writing transformations and stuff like that, you're not going to address the squared. It only makes a difference if you graph it. Okay. I want to direct your attention to, let's look at number 3, because number 3 is kind of funky. We're going to rewrite number 3. We're going to say 1 over 2 times x plus 0 plus 5. So what is the vertical asymptote? 0. And what is the horizontal asymptote? Okay. And then what are the transformations?
Vertical stretch of 2.
Wait, think of, yeah, it's a compression. Because it's a 1/2. Does that make sense? So last night we did one, or whenever you watch the video, we did one, I think it had a 3 on the top.
Yes.
And since it was a 3, that meant it was a stretch. But this is not a 2 on the top, it's a 2 on the bottom, which means it's kind of like a 1/2. So we're going to say that's a vertical compression of 1/2. So that's just something to be careful of. That's something that feels a little bit weird about these ones, okay? And then what's our other transformation? Up 5. All right. Pretty simple, huh? All right. That's all we're finding. We're just finding the equivalent of a vertex for this one, which happens to be the asymptotes, and then the transformations, okay? After that, it kind of follows the format of like a lot of the packets you guys have had from me so far, where then you graph some by making the chart, and then you find the domain and range of some, and then you find the increasing and decreasing of some, and then you find the x and the y intercepts of some. It just has you doing a few different things, okay? Now, I did not fix the packet to have it ask you questions like what is the end behavior. So we're going to go to the second page, the section where it says 21. Right here, it says find the intercepts for each of the following, and I'm going to say and end behavior, because there's no problem that made you find end behavior, and I want you to find it. Okay, so 21 through 24, find the x and the y intercepts, but also find the end behavior. Okay? Whew. We good? If I expect that this assignment should not take you all period. My guess is if you're working, you're probably going to get done with it like fairly quickly. When you're done with it, you should work on your cheat sheet. That's what I would like for you to work on it when you're done, okay? Because we review tomorrow and the test Thursday. Aren't you guys excited?
Yay!
Say it again.